So hello, and welcome to our session on optimizing file system costs using Amazon EFS Infrequent Access. My name is Duncan Lennox. I'm the Director of Product Management for Amazon EFS, and I'm joined today by my colleague Joe Travaglini, one of our Senior Product Managers on the EFS team. So we're really happy that you were able to join us today. We've got a lot of information we want to get through in the next little while. We're going to start off with an overview of AWS storage. Then we're going to move into an introduction to Amazon EFS itself. And then we're going to talk about Amazon EFS Infrequent Access, a new storage class that we've announced this week at reInvent that's coming soon for Amazon EFS. And we'll wrap it up and have some time for questions at the end. So a couple of logistical things to share with you as well. There are some related breakouts that you might want to know about. We have a deep dive on cloud file system offerings coming up tomorrow at the Venetian. And we're also doing a deep dive on Amazon Elastic File System. So in this session, we're focusing on the Infrequent Access storage class primarily. The deep dive session tomorrow goes into more detail about Amazon Elastic File System more broadly. And then tomorrow as well, there's the Got Files session where we're talking about a variety of our file and storage services. So let's talk a little bit about storage at AWS. So for over a decade, we've been innovating at a pretty rapid pace with storage at AWS. And we're really excited that Gartner and their clients continue to recognize AWS as a leader in storage with the highest positioning on both axes in their Magic Quadrants since day one. And what that's allowed us to do is over the last almost 13 years now, we've had a lot of conversations with customers and helped them move their workloads to the AWS cloud. And we take all that feedback of use of storage at scale, and we use that to drive our roadmap so that we can have a very broad and deep portfolio of storage options. At AWS, 90 to 95% of our roadmap is driven by customer feedback. And as we've had a lot of conversations with customers over the last decade plus, we've seen some adoption patterns emerge in how people start to migrate their applications to the cloud. So the first thing that we see is rehosting. This is where you take an existing on-prem application and move it usually with virtual machines into the AWS cloud. This is how we help Lionsgate migrate their SharePoint and SAP application into the AWS cloud. Then we talk about replatforming. This is where you take an existing application, move it into the AWS cloud, but take advantage of bits and pieces of the services that AWS provides. So with Amazon EFS, for example, we were able to help the BBC take their Red Button application and move it from on-prem into the cloud, where they could use Amazon EFS as a drop-in file system replacement for their on-prem application as they migrated it to the cloud. And then finally, we see rearchitecting, where applications are re-architected to take advantage of AWS services natively. And of course, this often applies to new applications as well. And what this has allowed us to do is build out a broad and deep portfolio that offers you more choice for storage options, so you can find the best fit for each individual use case that you have. Whether that's rehosting, which might involve using our block storage options like Amazon EBS, replatforming, which will involve file storage like Amazon EFS, or rearchitecting, where you're using object storage like Amazon S3 or Amazon Glacier. So when we talk about file storage, we're really talking about network file storage. And why does network file storage matter? Well, it turns out, of course, that a lot of unstructured data is out there in a file-based format. A large percentage of applications rely on file systems to operate. And what we want to make it easy to do with replatforming on AWS is to take those applications and move them into the AWS cloud. So with our fully managed file system services, that lets us take an application, move it into the cloud, and provide all the same file APIs that the OS expects to be there so that it's transparent and a drop-in replacement for your applications. When we talk about fully managed cloud file systems, today we announced two brand new file service offerings. So in addition to Amazon EFS, which we'll be talking about more today, which is our cloud-native file system storage service for Linux-based workloads, we announced Amazon FSX, and specifically two new fully managed file systems, Amazon FSX for Windows and Amazon FSX for Lustre. So Amazon FSx for Windows File Server is designed for Windows workloads. It provides native Windows capabilities in a fully managed environment. Amazon FSx for Lustre is designed for your compute-intensive workloads. It's based on the popular open-source parallel file system Lustre, but again is fully managed, so you don't have to deal with any of the provisioning or patches or other things that go along with running your own file system. But today, we're going to be talking about Amazon EFS. So before we get into the details of Amazon EFS Infrequent Access, our new storage class, let's step back a little and talk about Amazon EFS itself. So when we built Amazon EFS and launched it about 2.5 years ago, we had some core tenets that we used when we were designing and launching the service. The first is that we wanted it to be simple. Simple to create a file system, simple to manage. It's a fully managed file system. You don't have to deal with provisioning, hardware, managing software, or storage capacity. We take care of all of that for you. We also wanted it to be elastic. Elasticity is really important. It means you don't have to provision in advance the storage that you need. The file system automatically grows as you add data to it, and it automatically shrinks as you remove data from it. And our third core tenet is all about scalability. Amazon EFS is designed to scale to file systems of petabyte size, and throughput scales with the file system automatically as well as it grows. Across all of these three tenets, we wanted to deliver a highly available and highly durable file system, so you don't have to worry about the safety of your data. So Amazon EFS provides elastic and scalable file systems. We have 2 performance modes that allows you to optimize for different workloads you might want to run with your file system. We have 2 different throughput modes that allows throughput to automatically scale based on the size of your file system. Or if you want to, you can provision throughput and dedicate a certain amount of throughput to the file system. It's designed for shared access and massively parallel shared access. It can scale out to thousands of clients connected to an EFS file system. It's designed for high availability and durability, and it's designed to be secure and compliant. We support encryption in motion and at rest, and a number of compliance certifications such as PCI, we're HIPAA eligible, and so forth. So let's talk about availability and durability. Amazon EFS is designed to be highly available and highly durable. It's a regional service that is multi-AZ. It's across 3 availability zones in any region where you use EFS. So you can always access your file system from any of those 3 availability zones, and your data is automatically replicated across them as well in a highly durable fashion. 2018 has been a busy year for us. Since last year's reInvent, we've added a lot of new capabilities to Amazon EFS. We've added new regions in California and in Asia. We've also added a lot of new certifications like GDPR, HIPAA, and so on, PCI. Capabilities at the feature level that we've added over the year included things like provision throughput that I was just talking about, and we've increased things like the number of locks that you can have per file, the number of file systems that you can have per account, and added multi-VPC access, which we just announced today. Amazon EFS is now available in 10 regions around the world, and we're excited to be coming to London and GovCloud soon as well. So let's talk a little bit about the economics of Amazon EFS. Firstly, we have no minimum commitments or upfront fees. You pay only for what you're using. You don't need to provision storage in advance. The file system automatically grows and shrinks as you use it and add and remove files. And there are no other fees or charges for using Amazon EFS. So before we launched Amazon EFS, what customers had to do was build their own DIY shared file storage. And this involves procuring and provisioning hardware, both the compute instances and the storage hardware, managing software, including updates of those software. If you wanted to have a highly available file system, you would have to build it in multiple availability zones and then manage the inter-AZ traffic and have software to do the replication for you as well. We've taken all of that and moved it into a fully managed service where we take care of all of that for you. So let's look at a TCO example. before we get to the infrequent access storage class that we're going to talk about today. So if we take an example of storing 500 gigabytes of data on Amazon EFS, you would pay only for that storage. So if you're using 500 gigabytes, you would pay, using our US East 1 pricing, Northern Virginia, 30 cents per gigabyte month for that. So $150 per month for a highly available, highly durable, managed NFS file system. If you're running your own DIY system, firstly, you'd probably have to provision more than 500 gigabytes of data because you've got to be sure you can handle the maximum capacity you think you're going to need with your users. So let's say you go with 600 gigabytes of data. You're going to have to do that across at least 2 different volumes so that you can have high availability. That would cost you about $120 per month. You then are going to need the compute instances to actually run the software, and you're going to have the inter-AZ data costs. So that would cost you $530 a month alone, and that's not getting into any of the people or other management costs that you'd have. So on the basis of the services alone that you'd need to run this, Amazon EFS is 70% less than the do-it-yourself solution today. And that's before we start to talk about infrequent access, our new low-cost storage class. So I'd like to turn it over to Joe now to do just that.
Great. Thank you, Duncan. My name is Joe Travellini. I'm one of the product managers on the EFS team, and I'm really excited to be talking about the Amazon EFS Infrequent Access Storage Class, or EFS IA. So as Duncan was just talking about, EFS as a fully managed storage solution, you get high availability, high durability, elasticity as native features right out of the box. And customers always tell us that they love EFS's simplicity, how easy it is to use. At the same time, sometimes we get feedback that if you need to store a lot of data for long periods of time, EFS can be quite expensive. So we really wanted to look at ways that we could optimize and reduce cost. We've been in general availability for a little bit over 2.5 years now, so we had plenty of usage data to analyze. And we noticed a couple of trends. So one trend we noticed is that the older data gets after creation and loading into the file system, the less frequently it tends to be accessed. In fact, most of the data that customers are storing on EFS isn't really accessed that frequently at all. Many files not even accessed at all over any given month. So right there was an opportunity. How could we extend a lower cost while providing all the same features that customers expect today? And with EFS IA, that's exactly what we're doing. So coming soon, EFS IA is a new storage class that can reduce cost by up to 85% relative to the existing EFS storage class, which we're now calling EFS Standard. You can use EFS IA to cost-effectively store more data, more files in your file system, and expand your use of EFS to an even wider set of applications. And using EFS IA will be super easy. It's not going to require any changes to existing applications. EFS file systems will transparently serve data from both storage classes, Standard and IA. And to get data into EFS IA, we're introducing a new Lifecycle Management capability that you can enable for your file systems. So let's talk a little bit more about how EFS IA works at a high level. First, you create a file system. And like I just mentioned, after the launch of EFS IA, EFS file systems are going to transparently serve files from both storage classes with that common file system namespace. So you don't really have to worry about which files are being actively used and which ones are infrequently accessed. Next, you're going to enable the Lifecycle Management capability for your file system. And with that enabled, any files that aren't accessed for 30 days will automatically transition from Standard into IA. And by doing that, we're eliminating the need to manually manage your files and data to optimize for cost. And all EFS features are supported when you're using EFS IA. So when would you use EFS IA? Let's talk a little bit about use cases. So generally speaking, EFS IA is designed for cost-effectively storing files that aren't accessed every day. And we see applications of that nature in a couple of different areas. So first, sometimes you just need to keep data around for regulatory or compliance or audit purposes. You're just required to keep data around, even though you're not accessing it frequently. Other times, you might want to have a warm standby to quickly meet a tight recovery time objective in a failover scenario. And we also have customers running simulations or other types of iterative algorithms in the data analytics space. So, anything from genomics and life sciences to oil and gas, electronic design automation, geospatial analytics, and other examples of that nature. And another area where EFS IA can be a really good fit is in the document management space. So generally a reporting system, but things like legal research or HR staffing systems where you have a whole treasure trove of documents that you're not accessing very often, but they need to be readily accessible, and they're pretty well served by file-based semantics and file-based applications. Okay, so let's get to brass tacks here a little bit. We'll go over the price structure for EFS IA, and then we'll move on to more technical detail. So as I mentioned before, we're now calling the existing product of EFS the standard storage class. That pricing isn't changing. It's an all-up price of 30 cents per gigabyte per month, and you pay only for what you use. That's our general purpose file system offering. And now with the introduction of EFS IA infrequent access, that's cost optimized for files that aren't accessed every day. So there are two price dimensions. You pay for storage in the amount of 4.5 cents per gigabyte month, and you pay a small fee each time you access the data, and that is 1 cent per gigabyte. So having that price structure allows us to extend the lowest possible storage price for infrequently accessed files. And just want to point out that these prices are for the US East 1 region. In other regions, IA will be priced similarly relative to standard. Okay, so with that out of the way, let's dive a little bit deeper on lifecycle management and how that works. So at the launch of EFS IA, lifecycle management will use a predefined policy that automatically moves files after 30 days of not having been accessed. So for file systems that you create after the launch, you're going to be able to enable or disable lifecycle management at any time. Once lifecycle management moves a file to the IA storage class, it will remain there. But if you need to bring it back into standard, you can always create a new copy of that file. For the purposes of lifecycle management, EFS is keeping an internal timer per file on when it was last accessed. And what do we mean by access? So an access is defined as a read or a write to the file. So file metadata operations, things like listing the contents of a directory with ls, those don't count as access, and those don't reset the timer for lifecycle management purposes. And speaking of metadata, any file metadata itself, things like the file name, the owners, the attributes, we're always going to keep those on EFS standard to provide consistent metadata performance across both storage classes, standard and IA. And I'll talk a little bit more about IA performance in just a little bit. And another thing we're also always keeping on the standard storage class at launch are files that are 128 kilobytes in size and smaller. And we're doing that to provide the best experience at the lowest possible cost. Okay, so on the performance front, the latencies for standard and IA. So EFS standard storage class, you can expect on average single-digit millisecond latency, whereas for files that are stored on EFS IA, you can expect low double-digit millisecond latencies for reads and writes. That said, you can drive the same level of throughput against files stored in EFS standard and files stored in EFS IA. And that's regardless of which throughput mode you're using. You can be using the bursting throughput mode or even EFS provision throughput. So one thing to keep in mind there is that the baseline throughput your file system can drive will work the same way it works today, and that's based upon the storage capacity in the EFS standard class. And the baseline throughput's used to calculate your bursting rate, as well as to calculate the amount that you build if you're using provision throughput. Finally, on the lifecycle management aspects and the transitions, those occur in the background at a lower priority than active file system workloads. So until a file is fully transitioned from the standard storage class into the IA storage class, EFS treats it as being on the standard storage class and it is billed at the standard rate. Okay, so just wrapping up a few things here, and then on how we're metering and billing. So from the storage perspective, IA storage and standard storage are metered exactly the same with 4 kilobyte increments. Data access is metered in 1 megabyte increments. And again, data access, from a metering perspective, we're really talking about the reads, and I would say writes, but you could be more precise and say lifecycle transitions. So why am I saying lifecycle transitions and not writes? Well, all writes will originally land on EFS standard, and then Lifecycle Management will transition the content into IA. So that goes even for files that have already moved into the IA storage class. When you update a file that is already on IA, the content will first land on standard, and then Lifecycle Management will transition it to IA a maximum of once per day. So you don't have to wait 30 days to update it. We'll do that once per day. And when you look at your bill, in addition to the standard storage and provision throughput that you see today, you'll have infrequent access storage and reads and writes separately, all broken out on your bill. And it's super easy to get started. What you'll have to do is just click a checkbox in the EFS console if you're using the console. We'll have documentation as well on how to use the CLI or the SDK. But it's really easy. It's just a single toggle on your file system to enable lifecycle management that automatically moves the files after 30 days of not being accessed into the IA storage class. So I'm going to sum things up here and go back to that TCO example that we showed you a few minutes ago. So again, before EFS IA even, if you wanted to build a do-it-yourself file system and you wanted to cost optimize your footprint based upon your data access patterns, what you'd have to do is you'd have to set up not only the EC2 instances for your file servers, but maybe you choose 2 different storage tiers. Maybe you choose EBS GP2 for your general purpose file storage, and maybe something like EBS SC1 as a colder offering for infrequently accessed files. And you'd have to manually manage the data between those things. And you still, if you wanted high availability, have a replicated setup in 2 AZs, and then manage that replication process as well. So with the introduction of IA, if we incorporate that into our TCO example, you can see again for storing 500 gigabytes, where let's say 80% of the data is infrequently accessed. That comes out to about $52 per month on EFS. But if you were doing a comparable, do-it-yourself file system using EC2 and EBS, it actually comes out that EFS with EFS IA is more like 90% as opposed to 70% more cost effective. And again, these are just the hard costs in terms of your infrastructure pricing. It doesn't factor in the soft cost components. So that's really it. That's what we wanted to share. Love to talk more after the session. If you have questions, you can also visit our website, check out the resources that we have available, a lot of great detail on customer use cases and case studies. And we have a GitHub repository with some tutorials. So with that, thanks for listening. Really excited to see how customers are going to adopt the EFS IA, and love to hear feedback on what you'd like to see from us next. Thanks. Any Q&A?
Actually, I do have a question. Is there potentially an IA offering for the new FSX Windows and Lustre-based file systems?
Yeah, not at the launch of that. That's a pretty interesting idea. I can definitely connect you with the FSX folks to talk more about that.
Yeah, I'm just curious. I figure if you're doing it for EFS, I'm assuming the trend will be similar for the Windows and the Lustre-based file system that you offer. Okay.
Is 30 days a fixed value, or is that just default?
So the question is the 30 days a fixed value, or is it the default? It is the default fixed value at launch. That is available at the launch. We would love to hear more feedback on different use cases. If you have different requirements, whether it's time-based or even other dimensions, our roadmap is driven by customer feedback. So we kept it super simple at launch, and we'll continue to iterate based on feedback.
From an audit perspective, how do you prove that something was
Yeah, so the question is, from an audit perspective, how can you tell when a file was in a particular storage class at a particular point in time? That's a great question. That capability isn't available at launch, but that's a really good question, and stay tuned for more things in the future.